Welcome to this lecture on confidence interval. We are going to be looking at two cases. The first case is where your sample size is greater than or equal to 30, or the population standard deviation, sigma, is known. Now, what are the objectives? We want to look at how to find a point estimate and a margin of error. Then we will move on to construct and interpret confidence intervals for the population mean. And then we will determine the minimum sample size required when estimating mu, which is the population average. Now, it's always important for you to distinguish between population and sample. The sample is simply a representative subset of your population. So a point estimate is a single value estimate for a population parameter. The population parameter can be the mean, it can be the proportion, it can be the standard deviation, variance, and so on. So when you estimate it, of course, estimation is coming from the sample. If you had population data, then we don't talk of estimate. But because you do not have population data, you take a representative sample in order to estimate the population parameter. And in this case, we will be focusing on the mean. Now, we are saying that the most unbiased point estimate of the population mean is simply the sample mean. And this is an example. In this example of 40 employees, the question says, find a point estimate for the population mean mu. We have sample data, so we are simply going to calculate the sample mean, and it will be the most unbiased estimate of the population mean. And there we go. We sum all the numbers, divide it by the sample size, and we end up with that. That's it. We move on to the next concept, which is interval estimate. So the point estimate is looking at a specific number. It's 1 point. But the interval estimate is looking at an interval where you have a lower endpoint and an upper endpoint. So we are simply saying that at a certain level of confidence, it's going to fall within this interval. So that's the idea behind it. So we will look at the margin of error, which is simply the greatest possible distance between the point estimate and the value of the parameter it is estimating for a given level of confidence. So at a certain level of confidence, for example, 95 or 90, the margin of error is simply the distance between what you estimated and the true value. Of course, we do not have that value. So how do we compute it? We simply use this equation. Now note, here we are using the z-score. You use the z-score only when you know the population standard deviation, which is here, or when your n is greater than or equal to 30. So we say ZCY because you are looking for the Z at that particular level of confidence. We generally call this the critical value. Let's move on. So basically, this is how you use your margin of error to compute your confidence interval. So we are trying to estimate the population mean, and this will be the lower. So this will be the lower interval or the lower bound, and this will be the upper endpoint. Now let's take this example. It's important for you to be able to compute the margin of error, given that with the margin of error, you can always construct your confidence interval. If you remember, this is always what you need to look for. Now, always remember what condition needs to be met for you to use this formula. Either your n is greater than or equal to 30, or you know the population standard deviation. Then you can use this formula in order to compute your margin of error. So in this case, we've been told that in a random sample of 20 students, you have 20. So your n is less than 30, your n is 20, the mean is given, the standard deviation is known to be 1.5 years. So in this case, we know the population standard deviation, so you can use that formula to calculate your margin of error, and the confidence interval is 90. So once you have a confidence interval of 90, you simply go to your table and look for the critical value. Once you have it, you can plug it in that equation. Remember, your n is 20, standard deviation is 1.5, and the critical value is 1.64. In a subsequent video, I'm going to show you how we obtain these values. And once you have that, given that the mean, so the mean has already been found, this is your x bar, you will now use your margin of error. It will be mean plus or minus your margin of error. So here we go. This is your mean. This is your margin of error. You have your left endpoint and you have your right endpoint. That is all you need for computing your confidence interval. You compute the point estimate. Generally, it's given. You compute the margin of error, and then you use it to extract it. And generally, it's very important to stick to how the conclusion is formulated. We can say in this case that with 90% confidence, you can say that the mean age of all students is between that. Now, how do we compute the sample size? It's the same equation, that the margin of error equation, that we have flipped in order to use to compute sample size. Definitely you need to know how to compute the sample size. This is its equation. This is the critical value. This is the population standard deviation. And this is the margin of error. We need it to be able to compute that. So let's take this example. In this example, you've been told that your confidence interval is 90, but you've been told that your level of confidence is 95%. You've been given the standard deviation and you want to use it to do your computation. We have also been told, this is where you have to be careful. It says confident that the sample mean is within 7 friends. So this is your margin of error, 7. So when you come here, you infer remember here we have 95. If you go to your table, your ZC will be 1.96. Sigma has been given. And so this is basically it. And you now have 7. Now you basically want to compute your n. If you plug that in, that's where you end up with. Okay, right now I'll show you how to infer this value in the table. If you go to the tables that were given in class, if you go to the 3rd page, if you scroll all the way down to the 3rd page, you're going to find confidence interval critical value tables. So your ZC is given by this table. So for example, if you are looking for the critical value of a C of 80, it's already given. So these are the major C's which are always given. So the major level of confidence. Now, note that there's a typo here. This should be 90, okay? 0.9, 90, 0.95, 95, 0.98, 98. These are the values. So initially we started with 0.9, which is 90. We had 1.645. The next case was 95, where we had 1.96. So this is where it's coming from. If you have any question, just come to the 3rd page. That's for confidence interval, and you will find your values here. So basically, it's from that table that we got the value. And now we move to the next case, which is quite easy also. In this case, it's the second case. We are simply saying we do not know the population standard deviation, and in this situation we use and. We do not know the population standard deviation, and the sample size is less than or equal to, is less than 30. The sample size is less than 30. In that case, we will use the t-distribution. Now, the t-distribution, this is the equation. You don't need to calculate this. You simply go to the table and infer. So how do we look for the critical value for the t-distribution? Let's say we have 95 and we have a sample of 15. We need to look for what is known as the degrees of freedom. It's always given as n-1. So when you are in a situation where you do not know the population standard deviation and your sample size is less than 30, in this case 15, you do n-1 to get the degrees of freedom, and you already have the confidence level. You come to your table, you are looking for C. This is your C, 95. You look for C. You look for where you have 95. This is 95. Degrees of freedom is 14. So where you see DF, it simply means degrees of freedom. You've already calculated it. It's n-1. So you will go to 14 and 95. And then the point of intersection will be your value. And this table for us, it is the fourth page of the document that was given. So if we come back to the table, if you go to the fourth page, you'll find that your C is on this line. You'll see that here you have 95. The degrees of freedom is here. If you go all the way to 14, if you take 14 and you look for where you have 95, this is your 95%, so it's 2.145. So this is how we look for the critical value for the t-distribution. Now let us see how to use it to a computation. So the only difference between the first case is that here you are using TC, but the other one you are using ZC. So two different tables, it's important to distinguish very well. In this case, we are told that we select 16 coffee shops. So the sample size is 16, your N is 16. The sample mean is 162. The sample standard deviation is 10. Note, everything is sample. 95% confidence level. So the first thing, you look for the critical value based on 16 and 95. Now note that you always have to calculate the degrees of freedom. So you'll do DF equals 16 minus 1. Then you will go to your table and look for 95 and 15. So that's basically what we are doing. DF is n-1, 15. When you go to your table, you will find that for that particular point, it's 2.1. Well, this is your critical value. After that, you simply plug it in your equation where the standard deviation is 10, sample size is 16, and this is your critical value from the student t-distribution. And with that, you plug it in your equation to obtain the left endpoint and your right endpoint. And that is basically it for this lecture. And that's your confidence interval.